Now it's time for what scares a lot of people, which is particle physics. This t-shirt is actually really naughty. Maybe it's the worst thing that I put in here, but particle physics gives me a hadron because it's a play on words. If we replace the R and the D, it's very naughty. But I've actually seen some physicists wear this kind of t-shirt. So anyway, we're going to talk about hadrons actually. So we got particle physics, and it all comes from a really basic idea, right? You take the atom, you take the pieces of the atom, like a neutron and a proton, or electrons, and you try to break them up into smaller pieces to find out, can they be broken up? Turns out electrons can't. So as far as we know, you can't split up an electron into any component parts, but neutrons and protons, they do break up into other particles. Those particles are called quarks. Those are, I think they have a background, I think it's in science fiction. I think there's a book, I can't remember the name of the book now, but they had quarks in them. So a lot of this is named kind of with a sense of humor. You see, a lot of the physicists here really had a good sense of humor about naming them. So they realized, imagine this is empirical, right? You do this, you split up a neutron, you just smash it together with something else at very high energies. You see it makes these other particles. So they had to give them a name, so they called them quarks. And it turned out there were 6 different basic types of these particles. So we're going to call them, these are the 6 types of quarks. So first we're going to say there's the up, well, we'll write them like this, UCT and DSB. And then I'll name them all. So U is called up. Now these names are kind of arbitrary, although some of them are kind of paired up for different reasons, which we don't quite need for IB. But U is up, C is called charm, T is top, D is down. We have S, which is called strange, which I think is a fun one. And you got B, which is bottom. So this is what you need. So you got up, charm, top, down, strange, and bottom quark. Those are those 6 basic quarks. However, each of the quarks has its antiparticle. Now, antiparticles, they have opposite properties. So, for example, charge, baryon number, we're going to talk about lepton number, and strangeness. So they all have opposite particles, opposite properties. So, for example, there exists something called the, we'll write them down again. So UCT, DSB. Except for each of them, we put a line on the top. So that tells us it's the antiparticle. So if you have a up, you have something called the anti-up. And if you have a charm, this is called the anti-charm. I hope you get the idea here. This is anti-top, anti-bottom, and so on. So I think this is actually really interesting because you have these antiparticles. And an antiparticle is really strange because if a particle meets its antiparticle, something very, very special happens. Okay, I'll just make sure I spelled this right. So anti-charm, top, down. Because when I'm talking, maybe there's a big chance I made a mistake. Okay, good. So for example, if you have a particle like an anti-up running into an up, so a particle and an antiparticle, if they meet and collide, they actually annihilate. They make, well, photons basically. So this is really interesting. For example, an electron and its antiparticle called the positron, that was something from the nuclear physics part. If an electron and its positron, they're opposite particles. If they meet, they disappear. We call it annihilation. They make photons. We're going to learn with the Feynman diagrams what that looks like. So basically, you just have to keep in mind there's particles and there's antiparticles. These are quarks. Now, the thing I think that causes a lot of students problems is this idea about this sort of the structure of this, like how they're organized and how they're structured. I think a lot of textbooks just write a bunch of sentences. They'll say, you can make a lot of particles out of quarks. You can say hadrons are made of quarks. You can have baryons are made of 3 quarks. Baryons are also hadrons. Mesons are made of 2 quarks, where 1 quark and an antiquark, and those are also examples of hadrons. I think what I said, by the way, is all true, and yet I think if you write it all in sentence form, it's not very clear. So I'm going to be repetitive to annoy you. But because I'm going to annoy you, you're going to learn the structure really well, sort of how they're related. Okay, so this is going to sound slightly annoying. If I'm annoying you, good. It means you know it. So what do we do with quarks? We have the largest scale structure with this is called a hadron. Or like this t-shirt, right? Particle physics gives me a ha-ha. So what do we do with quarks? Hadron is a particle made of quarks. So just think of that. There's nothing else needed. You take some quarks, and you make something out of it, that's called a hadron. That's it. I like to think about hadrons as heavy, so these are like the heavier particles. Now, within hadrons, if you're going to make something out of quarks, you can make two different types of particles. You can make something called a baryon, and that's when it's got 3 quarks. So again, baryons are just 3 quarks put together. You can have any of them, except obviously not an up, and it's anti-up because those will, annihilate. But as long as you have any quarks, any 3 quarks, or even anti-quarks, just choose 3 out of these 12, so long as there's never like a quark and its own anti-quark together. You can have like an anti-top and an up and an anti-strange, I guess. You'd have to check for conservation to see if it's possible. You could check the Feynman diagram, but if you can draw it, then it's possible. But if it's made of 3 quarks, we call it a baryon. That's it. So again, baryons made 3 quarks, and of course you made it out of quarks, therefore it's a hadron. So do you see the structure? Make something out of quarks called a hadron. If you make 3 quarks together, that's called a baryon, which is also a hadron because it's made of quarks. See, repetitive. So there are 2 types of particles you need to sort of memorize, or at least know the structure for. You need to know the quark makeup of a proton. So proton is going to be made up of this. It's going to be up, up, down quark. So it's got 3 quarks, right? See, 3 quarks. That's why it's a baryon. And because it's made of quarks, it's a hadron. It goes up, up, down. Now, does the order matter? No. You could say it's down, up, up. You can say it's up, down, up. It doesn't matter. The fact that it has 2 ups and a down, that's the important part. A neutron, however, is up, down, down. So it's very similar to the proton, right? It's only that there's a difference between one of the ups is a down. This is a little bit lame how I remember this, okay? But because you do need to know this. Okay, so I'm going to put this maybe in green here to circle it. So you do need to know this one, and you do need to know this one. Those could be asked. It's implied, at least. You'll need to know the makeup in order to continue. It's kind of lame, but I remember that both of them end in a down. So those are sort of the same. The way I remember the difference between a proton and a neutron, I think like pro means, we kind of use like the word like positive. If you're positive about something, you're pro something. So look at this. You're up, up. It's almost like, you're feeling like up. So you're very uplifted. So it's like you're very, very happy. So that's why you're pro. Whereas a neutron, you're sort of neutral. Look, you're up, but you're also a little bit down. You're in the middle. You're neutral. So I remember that the up, down, that makes me think of neutral. If that's really too lame for you, no problem. Just remember these and you're fine. Okay, so those are the 2 baryons you need to know about. And baryons, remember, 3 quarks. And you're also a hadron because you're made of quarks. There's another type of hadron, though. What if, instead of making 3 quarks together, you put in 2 quarks together where one is a quark and one's an anti-quark, but not its own? Remember, because if you put a quark and its anti-quark together, they disappear, they annihilate. So look at this. A meson, it's a particle made of 2 quarks, like I said, a quark and an anti-quark. An example could be the positive pion. You don't have to memorize these ones. You'll be given the quark makeup of these things. But for example, there's one called a positive pion. That one, its quark makeup is, let's see here, that would be up and anti-down. Do you see? There's only 2 quarks together. There is a particle and an antiparticle. So this is a meson. This is a real particle. You can actually find this in nature. Some of them are very short-lived, for example, but this is a positive pion, it's called. So this is really important. Again, remember, if it's made of a quark and an anti-quark, then it's a meson. And remember, mesons are hadrons because they're still made of quarks. So this is how we could sort of break it all down here. So we've got other particles as well called leptons. These are, because remember, we've got these basic fundamental particles, these quarks. Remember, we've got these 6 and the anti-quarks. We've got other types of particles called leptons. I try to think about the lighter leptons, just like I think of the heavier hadrons. That's what I think about. So lighter leptons and heavy hadrons. There are 6 types of leptons as well. So let's put those down. These go as follows. There's one called tau. At least we call it tau. I heard there's one of my students, she's Greek, she told me they say it, I think they pronounce it taf in Greek, but I'm going to call it tau. I'll ruin it. Then we have mu, and then we have E, the electron. So this is the tau. By the way, these all have a negative charge. I'll put a little minus to the top right here just to make sure we know. So this is called the tau. Some people call it the tauon. This is the mu particle, so some people call it the muon. This is the electron. Hey, that's a particle we know. Then we've got something else. Here, you got these neutrinos. That's why we use the Greek symbol nu. Isn't that clever? Neutrino. And we have these little subscript. We're going to have 3 different neutrinos. It looks like a V that's had one of its branches sort of blown away. Looks like a lot of wind has been blowing on this one, sort of bent it. So we put a little subscript. We have a subscript tau. We have a subscript mu, and we have a subscript e. Do you see? In other words, we call this the tau neutrino. Okay, that's what we call this one. We call this one here the mu. Whoops, I should say the mu neutrino, or the muon neutrino, some people say. And this one here is the electron neutrino. Now, of course, we have the 6 antiparticles as well. So we have the anti-tau, the anti-mu, the anti-electron. We have the anti-tau neutrino. I'm going to put the anti-symbols on top of them in a second here. So what happens here? We have this on top, this on top, this on top, this on top, this on top. Those are the antiparticles. Remember, this is the anti-tau and so on. So I hope you understand this. Keep in mind, though, this particle right here, remember, it has opposite charge. So if this had a negative charge, you could technically say this is, you could also write it like this, couldn't you? You could say it's a mu plus. That's also another way of writing this. Just like this, you could write it instead of the electron with a minus charge, you could also write it like this with a plus. By the way, this one has a special name. That's called a positron. So see, we have this electron and its positron. Those are the antiparticle pairs. And of course, it's called the anti-tau neutrino. This is the anti-mu neutrino and so on. And very finally then, I think we have a nice way we can represent the particles. If we write sort of a line like this right here, then we can actually write them all down. So we can say, for example, I like to put the U and C and T, and we'll split them up, and we'll put D, S, B. So these are all the different particles we know of. This is like our zoo of particles here. These are the quarks, aren't they? So these right here, these are the quarks. And remember, if we put things together, if we make things out of them, these are called hadrons. Remember, I'm just trying to put everything together so we remember them, hadrons. And remember what kind of hadrons we have? If we have a baryon, remember what that is? That's 3 quarks. And if we have a meson, remember that's 2 quarks, where one is a quark, one's an antiquark. And on the top here, we're going to have our, instead of hadrons, we're going to have our leptons. Those are the other basic particles. Remember, we can split those up and we can say, all right, we have the tau, mu, and electron, and then we have these 3 right here. These are the different neutrinos. I'm just putting them all down right here just so we can, and I'll put little negative charges maybe on them, just like this. But these are the actual antiparticles here. And these right here have little tau, and mu, and electron. These are all our different particles. So this is it so far. These are all the particles. I think it's a nice way to represent it this way. I actually saw this on a movie called Particle Fever, and I really loved how they described it. I think it's a lot better than the ways a lot of other people show them. So that's why I use this.